Our solar system is a place of wonder, filled with a dazzling array of celestial objects. Among them are the moons, natural satellites that orbit planets and dwarf planets. These moons come in all shapes and sizes, from the colossal Ganymede, larger than the planet Mercury, to tiny, irregularly shaped bodies just a few kilometers across. Each moon holds a unique story, a tale written in rock and ice, shaped by the forces of gravity and time. One such story is that of Francisco, a small distant moon of the ice giant Uranus. Francisco is a relative newcomer to our awareness, its existence only confirmed in the early 21st century. Despite its diminutive size, Francisco plays a crucial role in the intricate gravitational ballet of the Uranian system. It is one of the outermost moons of Uranus, residing in a region populated by a retinue of small, irregular satellites. These moons are thought to be captured objects, ensnared by Uranus's gravity long ago, their origins shrouded in the mists of time. The study of Francisco and its brethren offers a unique window into the formation and evolution of planetary systems. By piecing together the clues held within these celestial time capsules, we can begin to unravel the mysteries of our solar system's distant past. Join us as we embark on a journey to the realm of ice giants, where we'll explore the secrets of Francisco, a tiny moon with a grand tale to tell. Francisco, like all celestial objects, is engaged in a perpetual dance around Uranus. Its eccentric and inclined orbit reveals a complex gravitational interplay. Likely a captured object, Francisco's path is shaped by gravitational tugs. Its orbit takes 2.5 Earth years, experiencing tidal stress. This dance offers insights into the dynamics of the Uranian system. Peering across the vast cosmic gulf, astronomers face a daunting challenge, deciphering the nature of a celestial object as small and distant as Francisco. Imagine trying to discern the details of a pebble on the moon from Earth. Despite these limitations, scientists have gleaned valuable information about Francisco's physical properties. One fundamental characteristic is its size. Francisco is truly diminutive. Its diameter is estimated to be a mere 22 kilometers. If Earth were a basketball, Francisco would be a sesame seed. Francisco is an irregular moon, shaped by collisions and gravitational interactions. Gazing upon Francisco, we see a world shrouded in mystery, its surface hidden beneath cosmic darkness. Its small size and immense distance make it challenging to discern any details. Scientists guess it's an ancient, heavily cratered landscape. Francisco's surface bears the scars of billions of years of impacts. Without an atmosphere, it's been relentlessly pummeled. The craters reveal clues about impacts in the Uranian system. Larger impact basins hint at past geological activity. Francisco's surface composition is another mystery. It's likely composed of water ice mixed with dark, organic compounds. These dark materials make Francisco faint and difficult to observe. While directly sampling Francisco's surface remains a distant dream, astronomers study its light interactions to understand its composition. Analyzing the spectrum of reflected sunlight reveals the moon's chemical makeup. Francisco is believed to be primarily composed of water ice mixed with dark materials. These materials include carbonaceous compounds and silicates. Their presence helps us understand Francisco's formation and evolution. Francisco is far from being alone in its cosmic dance around Uranus. It is one of many irregular moons, named after characters from Shakespeare and Alexander Pope. These moons are small, irregularly shaped, and have eccentric orbits, suggesting they were captured by Uranus's gravity. Despite their similarities, they exhibit diverse surface properties, hinting at varied origins. Studying these moons helps astronomers understand the history of the Uranian system and planetary formation. Imagine a vast cosmic dance floor, dimly lit by the distant sun. On this stage, Francisco, a tiny moon, performs a slow and intricate waltz around its colossal partner, the ice giant Uranus. This celestial dance is not a simple circular waltz, but rather a complex and elongated ballet, governed by the invisible hand of gravity. Francisco's orbit is a testament to the intricate interplay of forces at play in the outer reaches of our solar system. Unlike the inner moons of Uranus, which gracefully glide along nearly circular paths above the planet's equator, Francisco takes a more eccentric route. Its orbit is highly elliptical, resembling a stretched-out oval rather than a perfect circle. This means that Francisco experiences significant variations in its distance from Uranus throughout its orbital journey. At its closest approach, Francisco ventures relatively near Uranus, experiencing a surge in the planet's gravitational embrace. Then, as if flung outwards by a cosmic slingshot, Francisco swings far out into the darkness of space, its distance from Uranus increasing dramatically. This ebb and flow of gravitational influence create a constantly changing environment for the little moon. Adding another layer of complexity, Francisco's orbit is also significantly inclined. Instead of orbiting within the same plane as Uranus's equator, Francisco's path is tilted at a sharp angle. Imagine a hula hoop representing the plane of Uranus's equator, and then picture Francisco's orbit as another hula hoop tilted at an angle, intersecting the first. This inclination is a telltale sign of Francisco's likely origin as a captured object, its path shaped by the gravitational tug-of-war of other celestial bodies. Francisco's intricate dance around Uranus is not a solo performance. It takes place amidst a celestial ensemble, with other moons sharing the stage and influencing its movements. The gravitational pull of these neighboring moons, particularly the larger ones, creates a complex web of interactions that subtly nudge and tug at Francisco's orbit over time. Imagine a group of dancers moving gracefully across a ballroom, their individual steps influenced by the presence and movements of those around them. Similarly, Francisco's orbital path is constantly being shaped by the gravitational choreography of its fellow moons. These gravitational interactions can cause subtle changes in Francisco's orbital parameters, such as its eccentricity, inclination, and even its orbital period. For instance, a close encounter with a larger moon could give Francisco a gravitational kick, slightly altering its trajectory and potentially even pushing it into a slightly different orbit. Over vast stretches of time, these seemingly minor adjustments can accumulate, leading to significant changes in Francisco's orbital dance. The study of these gravitational interactions is crucial for astronomers trying to reconstruct the history of the Uranian system. By modeling the movements of Francisco and its fellow moons, scientists can rewind the cosmic clock, tracing their orbits back in time to understand how they may have formed and evolved. These models can also help predict the future evolution of the system, revealing potential close encounters or even collisions that might occur millions of years from now. Francisco's orbit, far from being static and unchanging, is engaged in a slow but relentless evolution over time. Like a river carving its path through a landscape, the gravitational forces acting upon Francisco are constantly reshaping its cosmic journey. Understanding this orbital evolution is crucial for unraveling the moon's past and predicting its future. One of the primary drivers of Francisco's orbital evolution is the phenomenon known as tidal forces. These forces arise from the difference in gravitational pull exerted by Uranus on different parts of Francisco's body. The side of Francisco facing Uranus experiences a slightly stronger gravitational tug than the side facing away. These tidal forces create a subtle stretching and squeezing effect on Francisco, generating internal friction that dissipates energy. This energy dissipation over vast stretches of time can cause Francisco's orbit to gradually circularize, becoming less eccentric. In essence, the moon's orbit is slowly losing energy and settling into a more stable configuration. The rate at which Francisco's orbit evolves depends on a number of factors, including the strength of the tidal forces, the moon's internal structure, and the gravitational influence of other moons. By studying these factors, astronomers can estimate how long it might take for Francisco's orbit to become more circular, providing insights into the moon's long-term fate. A cosmic perspective. Francisco's orbit in context. Francisco's eccentric and inclined orbit, far from being an anomaly, is actually quite common among the irregular moons of giant planets in our solar system. These distant, diminutive worlds often exhibit similar orbital characteristics, hinting at a shared history of capture and gravitational interactions. For instance, Jupiter's irregular moons, such as Pasiphae and Calm, also follow highly eccentric and inclined orbits, far removed from the planet's equatorial plane. Similarly, Saturn's irregular moon Phoebe is on a retrograde orbit, meaning it orbits the planet in the opposite direction to Saturn's rotation. These shared orbital characteristics suggest that irregular moons like Francisco are not native to their current locations, but were likely captured by their host planets long ago. They may have originated in the outer regions of the early solar system, where they were scattered and perturbed by the gravitational influence of the giant planets. Some of these scattered objects may have had close encounters with the giant planets, losing energy and becoming gravitationally bound. These captured objects, their orbits shaped by the chaotic early solar system, became the irregular moons we observe today. Francisco's orbit, therefore, provides a valuable window into the dynamical history of our solar system. By studying its movements and comparing them to those of other irregular moons, astronomers can piece together a more complete picture of how these objects formed, evolved, and ultimately found their way into their current orbits. Francisco's distant dance is not just a solitary performance, but a vital clue in the grand cosmic ballet of our solar system's evolution. Francisco among its peers. A comparative look at moons. In the grand cosmic theater of our solar system, Francisco may seem like a bit player, a small moon orbiting a distant ice giant. However, when we broaden our perspective and compare Francisco to the vast array of moons that grace our cosmic neighborhood, we begin to appreciate its unique characteristics and the valuable insights it offers. Imagine a vast collection of celestial portraits, each depicting a different moon from our solar system. We see the colossal Ganymede, Jupiter's largest moon, its surface scarred by ancient impacts and volcanic activity. We marvel at the icy plumes erupting from Enceladus, a tiny moon of Saturn, hinting at a subsurface ocean that could harbor life. And we gaze upon our own moon, its familiar face illuminated by the reflected light of the sun. Within this diverse collection of lunar portraits, Francisco stands out in its own right. It is a diminutive world, dwarfed by the giant moons of Jupiter and Saturn. Yet its small size and irregular shape place it among a fascinating class of objects known as irregular moons, thought to be captured remnants from the early solar system. By comparing Francisco to other irregular moons, we can begin to unravel the mysteries of their origins and evolution. Did they form in the outer reaches of the solar system, where icy materials were abundant? Or were they once part of a population of objects that orbited closer to the Sun, only to be scattered outwards by the gravitational influence of the giant planets? Worlds of ice and rock. Contrasting Francisco with inner solar system moons. Francisco, an icy moon beyond the asteroid belt, contrasts sharply with the rocky moons of the inner solar system. Icy moons like Francisco have dynamic surfaces due to internal heating, unlike the geologically inert rocky moons. Studying these moons helps us understand the diversity of planetary environments. A tale of two giants comparing the moons of Uranus and Saturn. Uranus and Saturn possess a mixture of regular and irregular moons. Regular moons like Miranda and Titan formed from planetary disks. Irregular moons like Francisco and Phoebe are captured objects. Saturn's moons, especially Titan, are larger and more massive. This may be due to Saturn's greater gravitational influence. Despite differences, both systems show diverse surface compositions. Unique in its own right, Francisco's place in the lunar landscape. Francisco's small size and unique orbit make it a fascinating object of study. Its eccentric orbit hints at a dynamic past influenced by gravitational interactions. Studying Francisco helps us understand the chaotic early solar system. Each discovery adds to our knowledge of this enigmatic moon. Francisco and its fellow moons promise to reveal more secrets. A window into the past. Francisco and the formation of the Uranian system. In the vast cosmic tapestry, each celestial object holds clues to its creation. Francisco, despite its size, is no exception. Studying this tiny moon offers insights into the Uranian system's formation. Imagine the early solar system, a chaotic swirl of gas and dust. Giant planets like Uranus were in their infancy, shaping space. Francisco and its fellow moons were captured during this turbulent period. Francisco's eccentric orbit reveals the dynamical processes of the Uranian system. Unlike regular moons, Francisco's path suggests a chaotic origin. Its capture influenced the orbital evolution of other moons and Uranus's tilt. Francisco's composition, rich in water ice, offers clues about outer solar system conditions. These materials suggest Francisco formed beyond the frost line, where water ice could exist. Francisco's capture remains a mystery. It may have originated in the Kuiper belt or formed closer to Uranus within a primordial disk. Gravitational interactions likely altered its path, leading to its current orbit. Section 3. A laboratory for planetary dynamics, studying Francisco's chaotic dance. Francisco's intricate and ever-evolving orbit provides astronomers with a natural laboratory for studying the complex gravitational dynamics that govern planetary systems. By closely monitoring Francisco's movements and modeling its interactions with other moons and Uranus itself, scientists can refine their understanding of how celestial objects behave under the influence of gravity. One of the key areas of interest is the long-term stability of Francisco's orbit. While the moon's current path is relatively stable, it is not immune to the subtle but persistent gravitational nudges from its neighbors. Over vast stretches of time, these perturbations can accumulate, potentially leading to significant changes in Francisco's orbit. Astronomers are particularly interested in whether Francisco's orbit is chaotic, meaning that even small uncertainties in our knowledge of its current position and velocity can lead to large divergences in its predicted path over long periods. If Francisco's orbit is indeed chaotic, it suggests that its future trajectory is inherently unpredictable beyond a certain point. Such chaotic behavior is not uncommon in celestial mechanics, and it highlights the intricate and interconnected nature of planetary systems. Furthermore, studying Francisco's orbit can provide insights into the past history of the Uranian system. By running simulations backward in time, astronomers can explore different scenarios for Francisco's capture and its subsequent orbital evolution. These simulations can help to constrain the possible origins of Francisco and its fellow irregular moons, shedding light on the formation and evolution of the entire Uranian system. Section 4. Future Explorations, Unveiling More Secrets of Francisco and Its Kin. Francisco has revealed some secrets, but many mysteries remain. Future missions with advanced instruments will unlock these secrets. A dedicated mission to Uranus could study Francisco's composition and geological activity, providing crucial clues about its history. This mission would also offer insights into other irregular moons, refining our understanding of the Uranian system. Francisco, once a tiny speck, promises to unlock more secrets about the outer solar system. Section 1. Francisco, a tiny moon with big secrets. As we conclude our journey to the realm of Uranus and its enigmatic moon Francisco, we are struck by the profound sense of wonder and the vastness of the unknown that permeates our universe. Francisco, a seemingly insignificant celestial body in the grand scheme of things, has revealed itself to be a captivating world full of secrets waiting to be unlocked. Its discovery, a testament to the power of human ingenuity and the relentless pursuit of knowledge, has opened a new window into the formation and evolution of planetary systems. From its humble beginnings as a faint speck of light in the depths of space, Francisco has gradually revealed its secrets to us. We have learned that it is a small, irregularly shaped world, likely composed of a mixture of water ice and darker materials, sculpted by billions of years of impacts and gravitational interactions. Its eccentric and inclined orbit, a telltale sign of its captured origin, speaks volumes about the chaotic early history of the solar system, a time when planets jostled for position and countless objects were scattered far and wide. Despite its small stature, Francisco has provided us with valuable insights into the processes that have shaped our cosmic neighborhood. Its existence challenges our preconceived notions about the diversity of planetary systems and reminds us that even the most seemingly insignificant objects can hold clues to the grand narrative of our universe's evolution. Section 2. Awaiting the dawn of new discoveries. As we stand on the precipice of new discoveries, powerful telescopes peer deeper into the cosmos. Ambitious space missions beckon us to explore the Uranian system. Countless questions remain unanswered, each a thread to deeper understanding. What is Francisco's surface composition? Are there signs of past geological activity? How was Francisco captured by Uranus's gravity? What role did this play in the Uranian system's evolution? These mysteries await us as we venture further. Each discovery deepens our appreciation for the universe. Francisco stands as a testament to human curiosity. Exploration illuminates the unknown. We push the boundaries of knowledge. Francisco will captivate our imagination. The greatest discoveries are often unexpected. The journey of exploration is never over. It is a continuous process of discovery, fueled by our desire to unravel the universe's mysteries and understand our place within its grand design.